all of we know that for the ordinary conservative system, the Whittaker equations were dqj by dq1 is equal to curly k by curly pj, and dpj by dq1 is equal to minus curly k by curly pj qj. Okay, and h it was termed to be a constant function. Now if we will integrate all the equations in one, here j lies from 2 to n, so these are 2n minus 2 equations, and whenever we will integrate the equations present in 1, then we will obtain the expressions for qj and pj. Okay, and those expressions will be with respect to q1 in terms of q1, and also when we will integrate the first equation, there will be one constant of integration. When we will integrate the second equation, there will be one more constant of integration. So for all the equations, there will be some constant of integrations. These are total 2n minus 2 equations. So there will be 2n minus 2 arbitrary constants. So it is stated here that integrating the system 1, we can find qj and pj in terms of the variable q1 and 2n minus 2 arbitrary constants. So we are taking like those variables are c1, c2, c2n minus 2. Also qj, it will be a function of q1, h0. H0 is that very value of h. And then c1, c2, c2n minus 2. pj will be some function of q1, h0, and then c1, c2, c2n minus 2. Also, as discussed in Whittaker equation, P1 is minus K, Q1, Q2, Qn, P2, P3, Pn, and H0. So P1, it's a function of Q1, H0, and then C1, C2, C2, and minus 2. Why? Because we replaced the values of Q2, Qn, P2, Pn from those as in equation 2 and 3. So P1 is a function of these variables. Now if you want that these coordinates must depend on time t, so we were having the Hamilton equation dq1 by dt is equal to curly h by curly p1. From here we can obtain the value of t, and then we can evaluate q1 in terms of t. Replacing the value of q1 in 5, then 4, and then 2 and 3, we will obtain that the variables are dependent on t. Okay, so this is the formula with which we can obtain t, and then it is discussed here that by replacing those values of q1, we will obtain that the variables or the functions are dependent on t. Now let's define qj prime. It is dqj by dq1. Earlier we used qi dot. Dot is the derivative with respect to t. Here we are defining prime. So qj prime is the total derivative of qj with respect to the variable q1. Obviously q1 prime is 1. Also let's define the function p to be a function of q2, q1, q2, qn, q2 prime, q3 prime, qn prime. H summation 2 from j from 2 to n, pj qj prime minus k. Here the equation 9 is similar to that of the Hamilton equation, Hamilton function. So if we will compare both, and then we will use the Hamilton canonical equations, and then finding the derivative of p with respect to qj, and then finding the derivative of p with respect to qj prime, we will obtain that the equation 10 will be satisfied. Means d by dq1 of curly p by curly qj prime minus dp by curly p by curly qj is 0. These are total n minus 1 second order equations known as the Jacobi equations. The only thing that remained here is to obtain the expression for P. And we know that minus K is P1. So P is summation j from 2 to n Pj Qj prime plus P1. So explaining this, P will be P2 Q2 prime plus P3 Q3 prime plus Pn Qn prime plus P1, which can be further written like P2 dQ2 by dQ1 plus P3 dQ3 by dQ1 plus Pn dQn by dPn plus P1. dQ2 by dQ1, it can be written like dQ2 by dt into 1 by dQ1 by dt. Similarly, dQ3 by dQ1 can be expressed like dQ3 by dt into 1 by dQ1 by dt, and so on up to last. Now dQ1 by dt, it is in the denominator. So it is Q1 dot, taking it as the common part, we will have P2 Q2 dot plus P3 Q3 dot plus Pn Qn dot plus P1 Q1 dot. In the summation form, we can write it like 1 by Q1 dot into summation I from 1 to n Pi Qi dot. And now summation I from 1 to n Pi Qi dot minus L, it was equal to H. So this summation is equal to L plus H. So we obtained some relation for P as 1 by Q1 dot into L plus H. It is stated that summation I from 1 to n Pi Qi dot plus minus L is equal to H. Further we know what is L, it is T minus U. What is H, it is T plus U. So L plus H, it will be 2U. Also the kinetic energy is 1 by 2 summation Ik from 1 to n Aik Qi dot Qk dot. Now assume G to be the function Q1, Q2, Qn, Q2 prime, Q3 prime, Qn prime as defined like 1 by 2 summation Ik from 1 to n Qi prime, Qk prime. But these Qi prime can be written like Qi dot upon Q1 dot and Qk prime like Qk dot upon Q1 dot. So it is 1 by Q1 dot square, and in the upper part it is T. So P is 2T by Q1 dot. Hence H minus U, which is equal to T, is equal to Q1 dot square into G. From here Q1 dot will be H minus U upon G under root. And therefore replacing the value of Q1 dot for P, we will obtain that P is equal to 2 times under root of G H minus U. This is the function, and the equations obtained in 10 are known as the Jacobi equation. After that, we are having the principle of least action. It is nothing but the converse of the Hamilton action, Hamilton principle. So you can read it. It's really simplest one. With this chapter is finished. I think today it's enough. We will continue the lecture tomorrow again.